Hello, good morning. I'm very glad to be here to talk about our journey in building a distributed data access layer for a lot of different analytics and machine learning workloads. A little bit about me. My name's Ben, and I am a founding engineer in the Alluxio company, and I'm also the PMC member for the open source project Alluxio. So before I joined Alluxio, I worked in Google to work on the next generation large-scale storage system. And before I joined Google, I was a Ph.D. student in Carnegie Mellon, working on networking and distributed storage systems. Okay, so we will share some insights from the team Alluxio, how we view the world is going, the data world is going. So essentially, we see the journey to a more fragmented data world in today. So we see, first of all, there's just more and more data generated every day. According to the latest statistics, we see every day there are more than 2.5 EB data generated. And with all this amount of data is generated, it's natural to ask, like, what are these data? And how are we gonna do with this data? Where to store this data? And also in the near future, you can see as the more popularity of 5G technology, or the IoT technology, and even blockchain technology, people are just going to generate more and more data. So this will be more of a severe problem. The first problem is how, with a lot of this data, how we can consume them, how we can consume data in an efficient way to derive insights, derive value from the data. There will be more people, they need the data from they need more insight, different values from data, and also the different data products to be derived from the data. And next, we see is in the every 3 to 8 years, there will be a new technology emerging or new sets of technology emerging about new ways to store data, new way to provide data. And also it comes with the hardware change, hardware improvement, or even just like the new algorithms, new ways to architect softwares or distribute file systems. Yeah. So we see different trends deriving a new architecture in this world. The first way we see in the field is really a separation of compute and storage. Actually, a lot of companies, they are already on the track. They see in the past few years, in the past decade, people are talking about, oh, we have a coupled compute and storage. It provides a great performance because we move compute to data, so we can save the network cost and we can make the MapReduce really fast. However, nowadays, if you go to this lot of companies, they are either telling you, oh, we're separating our compute server pools with this storage pools. The reason is they have different characteristics or they scale. They want to scale in different dimensions. One is on CPU, on the resource, computation resource. One is on the storage. And the other reason is all the popular, for example, containerization orchestration frameworks emerging, like Kubernetes. People want to go with more elastic compute, but less so for the storage side. They have very different characteristics in nature. So people are doing this separation for compute and storage. And next trend we see is the hybrid and multi-cloud environment. So if you talk to companies founded maybe in the past 5 years, a lot of them are born on the cloud, like our company. We don't have a single box at all in our office or in any data warehouse. All the infrastructure is built on AWS or similar public cloud vendors. And moving to the cloud is true. It's just like it's taken for granted for a lot of new companies. And even for the legacy company or a little bit older companies, they are already aggressively looking at their cloud strategy, how they can leverage public compute, public cloud resource in the cloud vendors, or they still have they want to maintain their own on-demand or in their data warehouse, their resource, but how we can combine all the resources together to have more efficient architecture. And the third trend is we see a lot the rise of the object store. A lot of people are saying, oh yeah, in the early days, we were told HDFS is very cheap. It's the cheapest way to save a lot of bytes. Not quite so actually in reality. It takes a lot of money and human resource actually, and DevOps resource to maintain all the bytes on your HDFS. So since moving to object store is easier to maintain, and also it's cheaper for a lot of different companies. A third one is, the fourth one is we see a lot of, because there's a lot of companies, they have a lot of different data sources, different data silos. So they realize, okay, there are new ways to generate value from all different pile data. So how can I do this? How can I do a data analytics effectively across different data sources? So all these other trends we see in the field in the past, especially in the past 1 or 2 years. So if you see, this is a lot of the common architecture 10 years ago. People are talking about MapReduce co-located with HDFS. And this is great because it follows the paper published by Google 15 years ago. It's talking about data locality, great. But however, if you go to the data ecosystem nowadays, you see more and more different ways to process data, more specialized frameworks doing graph processing, doing streaming, doing or deep learning or machine learning workloads. And also you have all different choices on your storage. Like S3 is definitely one of the most popular, very popular one in the last few years. And also all the storage vendors, they try to come up with their own devices saying, okay, this is compatible with this big data analytics, and just plug it. Okay, so we see a lot of these trends. So people started from the co-located HDFS with their compute, like MapReduce, typified by MapReduce or Hive workloads. Then they go to more modern ways, saying, okay, I want to separate my compute and HDFS as a little bit in the same data center. I know like a lot of infrastructure engineers actually are working on this in different companies to separate this. And now they're talking about more, how I can burst my workloads into cloud, public cloud or private cloud, or how I can support more frameworks. I want to share my data between Presto and Hive or Spark and Hive because they are representing different analytics workloads. Or I have my data actually used even across different teams, analytics team and machine learning teams, how I can support data sharing without any application or source code change. And in the end, how we can enable, accelerate big data workloads on object stores. Object store is great, it's cheap, but it's not that performed if you just use them like plug and play in a way. So associated with this transition, we do see a lot of different challenges. One is how we can use HDFS well in a hybrid cloud. And if you just directly read data from HDFS, it typically can be over the network, a public network. It can be very slow or expensive. And also, copying data, like doing the typical ETL, traditional ETL, can be less efficient. And usually data scientist team, they don't want to involve their ETL team because that can be very a long process to wait. And also using HDFS, the HDFS has a connector to talk to S3, this kind of a public cloud storage. But this is typically not optimized for big data workloads. People are working on that, like on Spark, on Hive, MapReduce community, they're working on that. But still, fundamentally, object stores like S3 is not a file system. It has a lot of different design trade-offs there. So this has implications in security, in consistency, and in performance to the big data or analytics workloads. Also, how can we support more workloads, more frameworks? Copying data from one place to another can be, as I mentioned, can be very slow and expensive, and migrating applications can be hard to maintain, hard to manage. And also, how do we transit to object store? It's not trivial at all. It turns out a lot of people see a lot of performance hits when they just put object store there. So this is a big challenge for a lot of companies we see in the past few years. So what we're doing here, actually, we're saying, maybe it's time because the ecosystem is getting too complicated. Let's simplify it a little bit. How can we do this simplification? We add another layer, like in the past 60 years, there's no real advance in the computer science at all, but just adding more indirections, adding more caching. These are the two like commonly used techniques, again in different contexts. And here we're saying maybe it's a time we can do a data orchestration layer for the cloud. So what we mean here is we want to provide a layer, and this layer is not responsible for storing data reliably. So that's the job for the storage system. It's S3, or it's HDFS, or it's your favorite vendor storage. But that's not the job for this data orchestration. So what this data orchestration layer is doing is to provide really accessibility. So different applications can use different APIs or the same set of APIs to access the same set of data. And also elasticity. So compute, nowadays people are making compute more and more elastic, but how we can make data as elastic as compute? Because if you want data to be the persistent data storage layer, it's very hard to be elastic. It has to be, there's a lot of limitation, a lot of restriction. But once you get rid of this assumption, we need to be reliable data, but just for compute, the computational data, then you can do a lot of smart things. For example, for the hot data, you can make more replications. And for the cold data, because the reliability is handled by storage, let's just evict them off. So this can do the caching layer. And also can do more like data transition from one form to another based on the life cycle of the data. So these are the layer we're thinking can be very useful to the ecosystem, to the data ecosystem in the new era. So I'm talking about like a few cases, and in here, because Alluxio is the open source project we built as one, for example, one implementation for this new data orchestration layer. So what we do here is we show different new use cases we enable to in the data ecosystem. The first one is to accelerate the data frameworks on the public cloud. So for a lot of startups, for a lot of like a mid-sized companies, we see architectures like this. They build everything on AWS or Azure, and they use EMR or use their just Apache versions of this analytics, and using S3 as the single source of truth, which is great. It simplifies the architecture a lot. So one issue they commonly complain is about the performance. Writing to S3 is often a very painful process, especially given all this, if you have a scientific or machine learning like workloads, you have to write this to S3 repeatedly. And also reading data from S3 is really depends on the luck. I have some demos to show, but I don't think I have time to, for this session. I can do that in the office hour. So S3 performance, read performance is really, has a lot of variance. So what we provide here is if you add Alluxio co-located with your Spark workloads, and which is connecting to S3, and then in this case, we provide benefits like caching the hot data into the workloads. So this will get performance very stable, but also very good. And next case we're saying this new architecture enables is, for example, you have a on-premise data center. You have a data there because you are a hedge fund. Your data is your life. You don't want to really put your data in any form of public cloud. And also there is regulation. So, but you really like the resource, the elasticity aspect of the public cloud. So when you train the models, when you run big data workloads, you say, okay, if I'm waiting in my on-premise data center, I need for another 5 days to get my resource to run my machine learning workloads, to train my models. But if I just leverage public cloud, I can just click the button and get 200 EC2 machines. And I can start my machine learning training process right away. The problem is moving data, no one wants to do this. So if you have this data orchestration layer in the cloud to help move the data to where it is needed and really also replicate the data if the data is more needed, and then this will simplify the life for a lot of data scientists a lot. And the last one is really how do you use similar object store to replace your, for example, previous HDFS for budgets, for cost saving. And in this case, you can put this data orchestration layer there to co-locate it with workloads and still get the same or even better performance. And there are some advanced, more advanced use cases. For example, enabling talking to across different single cloud or multiple different cloud, building a data abstraction layer, or having data on the public cloud and using this to share data across different workloads like Presto workloads or Spark workloads. Yeah, so the key innovation we are providing here is we build a data locality. We try to bridge data locality by building a caching, smart caching inside this layer, so we can do intelligent multi-tiering caching. And we also do the data accessibility by providing the most popular APIs to different frameworks. And in the end, we also we can merge or we can manage multiple different storage systems into a single file system namespace. In this way, the data really becomes abstraction to applications, to data scientists, rather than the concrete storage systems. I will have more concrete examples of that. So this is how we do the data to improve data locality. So if some data is hot, and then we will Alluxio as one example of the data orchestration layer, will just cache this hot data closer to the computation. And in this way, you don't need, if you access the data access pattern is accessing data repeatedly, then you don't need to always go to the same data source to read the data. And this will be much closer, hopefully on the same, because we leverage data locality to expose data locality to schedulers, Spark schedulers or MapReduce schedulers. Hopefully it will not even use network to transfer data. And on the right side, a layer like this can also serve as a write buffer, a distributed write buffer. And you can write your data to this layer, and we can asynchronously propagate this data to, for example, your configuration, your configured the storage like S3 or HDFS. And also we see is this layer like us, we provide different APIs, popular APIs like HDFS. So if you use your applications is using HDFS API talking to the data, then no code change required. It's just like configuration change or URL change. You can directly talk to S3 or different version of HDFS or Swift or some other like Hitachi storage. And in this way, this transition or this is automatic, and this is also transparent to the applications. And what we see interesting is in the last few years, we do see more and more applications built directly on top of S3 APIs. So either because all the new storage, they are providing S3 APIs, compatible APIs, or because more applications are porting to the cloud and using S3. So we do see S3 is becoming more popular, much more popular in the near term. And another advantage here is we provide this namespace management. Just like you are doing your mount on your local machine, you can put a hard disk on your local machine, local MacBook, or put a USB key there. And from the user's perspective, you only see one single file system namespace. And we do this exactly the same thing to different storage systems, distributed storage and services or endpoints. So in this case, you can mount a S3 bucket into a Alluxio namespace, and you can also mount HDFS into a same Alluxio namespace. And in the middle, the blue namespace is basically it's a logical view for the data. And applications or data scientists, they don't need to really care about which version of HDFS, which library I need to use, and how do I manage my credentials for S3. And you just go to and access this logic file system. That's it. It can simplify the development and the management and also maintenance for the data team a lot. So yeah, so if we go further, you can also use a tool we provided to even mount Alluxio service as endpoint into your local MacBook using the POSIX API. So Alluxio will serve as just like a folder on your MacBook. And even inside this folder, there will be subfolders, and they will be backed by other storage services. But for data scientists, this can be very easy because because the legacy workloads, they typically assume this is POSIX interface, or for the new AI workloads, typically, a lot of times people they like to deal with local file folder. Yeah, so this is the view we see in the future. You may have different data sources. they may live in HDFS, or different HDFS can be different versions in different regions. You may have some legacy storage capacity from NFS, and you may also want to leverage a lot by the cloud storage resources like S3. And you are running different workloads, Hive, Spark, or TensorFlow. And even for the same Spark workloads, you have some on-demand resource, but sometimes you want to burst your workload into the cloud. So our vision is, once you have this data orchestration layer, the management and also the data migration part is totally transparent to the applications. And as application developers, you just need to worry about, just need to know about the logical data paths. And other than that, the data orchestration layer will just take care of this. Yeah, so because I'm now using my own laptops, so I will leave my demos in office hour, which is right after lunch, and I will do a demo to show how can run Spark over Alluxio and mounted by with two different buckets, one on S3, one on Azure. And from the Spark perspective, it's totally the same. It's just like a different folders in the same file system. And also I will run some TPC-DS benchmark to show the performance benefits if you run Spark on S3 versus a Spark on Alluxio on S3, and see how much benefit you can get by having data cached co-located with the compute side. So there's some more details related to how you can use like a layer like this. For example, on the Spark side, all you need to change is to change the file. If you work with Spark, you may know this is the most useful, most common way to deal with the RDD, right? You do the text file, and typically this is the HDFS URL, and now you just change HDFS into Alluxio. That's it. For Hadoop, because we are providing a Hadoop HDFS compatible API, you just do the Hadoop fs-cat. And do the POSIX, you can just simply using the local command to do the file system browser and doing like cat some file. And we also provide our own Java API, so you can just deal with the Java API to get the most handle and most control on the data. And this is the architecture. For example, we have it's similar to HDFS. We have the master node, which is handling the metadata service, and you can use different master nodes and use Zookeeper or Raft to coordinate the masters to guarantee high availability. And also we have workers, and different workers can be, Alluxio workers can co-located with Presto or Spark. In this way, you get performance benefits. And the unique thing about this architecture is we have the understore concept. So the workers and the masters can be backed by different persistent storage, like object store or the HDFS. And you can mount them together into the same namespace. Yeah, so because we are adding a new layer, so it enables a lot of interesting things. So first thing is the different read modes. Originally, you just read from data source, right? But now you have more different ways. You can either read from the data directly, or you can read, if the data is already cached in this layer, then read from this cached layer and get a performance benefit. Or even it's in the same layer, in the cache layer, but it's on the remote node, that's still possible to read and still benefit from that. And you can also specify, I want to read this data, but bypassing the caching. I know I only need this once. I don't really need it twice, so no need to cache. There's also flag to do so. On the right side, it's even more different choices. You can decide, I want to write to this layer only, or I want to write to the persistent storage only, or you can write to both because you need to read it back sometime later, and you want this write to happen synchronously. Or you can write to the layer first, and then asynchronously, this layer will propagate the data to the end storage. Or you can set, okay, I want more replications. I do more replication control for the data in this layer, so I can write to n different copies, n different workers. Or you can see, I want to write to Alluxio, and then asynchronously help me propagate this data into different and persistent storage, like S3 or Azure, to have that data mirrored. Yeah, this is some animation to show how you read. You can read this from this, if data is already cached in Alluxio space. Or if the data is reading, and it's not really already cached in Alluxio, and then you can read from the Android store directly. On the write path, you can write this data into Alluxio space only. So you just go to the master first. Master tells you, okay, this is the worker close to you. Write to this worker, and the application just write this data to the worker, same node. Or you can write data synchronously to both the persistent storage or the Alluxio worker. And you can also, because we have the new concept of new layer added, there will be new concept too related to TTL or pinging. You can say, I want this data pinging in this layer for maybe 1 day or a week. And you can also prefetch data, or you know the data is no more needed. You can just free the data, but the data is no longer will still live in the persistent storage. Or you can even doing data migration across different amount points to migrate data from one Android store to another. And we will help you to do that. So I will just show 2 use cases about this use case. One is a use case in China Unicom. And this is one of the biggest telecom company in China, serving 320 million user subscribers in China. So they are running Spark workloads on different clusters. Some are HDFS, some is using Object Store or HBase. And previously, they were doing the ETL to migrate data from one place to their HDFS to be consumed by Spark. So later on, they just decided to put one orchestration layer here. So for the Spark job, it's just very simple. I just see all different parts as different directories. I can just use this directory to access data directly, and this layer will help me to migrate data to ETL data and also doing the caching. And this turns out very useful for them to improve the performance by, they have some benchmark to say 5 to 10x. Another is about elastic machine learning process. So this is the hedge fund in Wall Street. What they do is they have their data in their on-premise data warehouse, and they want to use cloud, the resource in the cloud to burst the workloads. So what they do is turns out they use Spark in public cloud and use this data orchestration layer co-located with Spark. And once they need to launch the Spark job, they will just they will preload data into this orchestration, either preload or you load it on demand, and use this to replicate data, to manage the input data replication distribution, and this will greatly improve their performance, their model development performance. And they see previously they need to wait for multiple days before they get all the resource to begin their model training process. But now, because they can leverage the cloud resource more efficiently, they can start this process much faster and get this performance, get this end-to-end model training process much more efficient. Okay, so now a lot of enterprises are moving to this independent cloud and storage, and these are actually a lot of users. Because this is open source technology, so a lot of people, a lot of companies, they are leveraging this technology to power their internal data infrastructure, and this is a list of a subset of them. Okay, so I think this is my last. This is the last slide. I'm waiting to take some questions, or you can talk to me offline in the office hour.
Yeah, I was wondering if you actually have any stats on the improvements, with using Alluxio.
Yeah, so we do have there's a lot of articles or blogs online. I can send you some points later. Let's maybe exchange emails offline. But there are some articles talking about their performance gain. But to be clear, it really depends on the environment and also like how far your data is, and also how slow you consume your current I/O processing is. But we do see the further the I/O is from your compute, the better performance benefit you get. Yeah. There's one more.
One more question. How you handle the encryptions?
Yeah, so we do have it's very interesting because for a lot of, there are some, so there's some regulation in different countries about the data encryption, like what kind of data you can put into different continents. And we do see cases like, for example, the Barclay, they need to make sure the data is encrypted and also the data is only in memory to be compliant with the regulation. And they use, for example, companies like this, they use Alluxio to put, so their data is encrypted in the persistent storage and even encrypted when it's cached in this layer. But it's only get decrypted when the client or the application with the client is reading the data, and they will get the keys and do the decryption. And yeah, so this is basically the, on the high level, how the encryption, decryption story works with us. Yeah?
How do you handle failures? This looks like a distributed database to me.
It's not a distributed database, actually. It's a file system or a storage system because we don't deal with the schemas or, for example, the SQL queries. It is files and objects. But failures, yeah, that's a very important question. So there are different parts. For the metadata part, we have the component called master to handle the metadata requests. And the metadata requests, you can install multiple masters. So even one master is down because we're running either Zookeeper or using Raft to coordinate the different masters. So there will be standby master to take over the responsibility. Yeah. So that's on the metadata part. That's critical, and we really try to avoid a single point of failure. On the worker side, which is really the different servers serving the data is chopped into different blocks and spread across different workers. There are different ways. First, because we simplify the concept, we're not dealing with the data persistency or reliability. So even the data is lost, if the data has one copy or has its persistency in the Azure storage system or persistent storage system, we can always fetch it back. And this process is transparent. It's just like you hit some performance, a little bit code on the code read. And also, there's other cases. If you want to really make sure the data has high availability in Alluxio, you can explicitly set, I want more replications of this data. And we will just make this replication for you.